This is 4.4 dealing with the accumulation function. Now, accumulation function is essentially a function that accumulates area. So it's not going to be that much of a departure from what we've been doing already with integrals and the area under the curve. But it does bring up something called the fundamental theorem of calculus part 2. So give you a moment to pause it and copy it. Now, this bizarre looking expression indicates something very significant, that being the relationship between derivatives and antiderivatives. So what this means is that if you take a derivative of an integral, they essentially cancel each other out. Notice that you have some function f of t, and after you take the derivative of the integral, since one cancels each other out, you end up back just with a function of x. Now you may be thinking, what the heck does this have to do with anything? But here's essentially what it breaks down to. If you take a derivative of this integral, sort of like when you take an ln of e, they cancel out. Whenever you square a square root, they cancel out. I indicate that this cancels out the integral. And what I can do is I can just swap in this top variable into there, and my answer comes out to be f of x. Now I'll do a separate video as a bonus as to why this is true. But all you have to really, I guess, remember is that a derivative of an integral cancels out, and you're able to swap in the top variable in for there, and that's it. Alright, so the bonus video if you want to see why this is true. But for now, we can just kind of work off of that and go over some examples. So first is we're going to let f of x be this integral, and I want to find the following of these two first problems. Now, this is just saying plug in 0 in for x. So I don't have to use the fundamental just yet. All I'm doing is taking the integral from a negative pi, and the top variable is going to turn into 0. And then it's going to be a cosine of t dt. So I evaluate this like I would normally. I would take the antiderivative, which is going to be a sine of t. Lower limit's going to be negative pi, upper limit's going to be a 0. And then I would just plug in the top limit and the lower limit. So this is going to be a sine of 0 minus sine of negative pi. And sine of 0 is a 0. Sine of negative pi is also 0. So essentially my integral, my value here, is going to be a 0. So I can say that f of 0 is equal to 0. So this really just has practice on finding antiderivatives and using the first fundamental theorem. And then for this one, the same thing, I'm plugging in pi over 3 as my upper limit. So this is going to turn out to be the integral from negative pi to pi over 3. And so this is going to be cosine of t dt, which is going to be positive sine of t from negative pi to pi over 3. Then I plug in my top limit, so sine of pi over 3 minus sine of negative pi. Well, this sine of negative pi we already saw was 0. So I don't really have to worry about this part. And then I just have to worry about what is sine of pi over 3 equal. Sine of pi over 3 is going to equal square root of 3 over 2. And that's what f of pi over 3 is based on this function. So f of pi over 3 is equal to square root of 3 over 2. So that's basically what the first half of accumulation functions are, is plugging in numbers and evaluating normally. For part B, now I want to find the derivative of this and evaluate 5 pi over 6 at that point. Well, if I take a derivative of f prime, that means I take a derivative of this integral function. So negative pi to x cosine of t dt. And this is where I use the fundamental theorem of calculus. Because notice I'm taking a derivative of an integral, which the kind of essential steps is that the derivative and the integral cancel out. So that means I can just cross this off, cross that off, and I can swap in this variable in for x, and that's going to be f prime of x, as a weird looking x, f prime of x is equal to cosine of x. Now what I can now do if I want to evaluate f prime of pi over 6 is just plug in 5 pi over 6 into this, so it's going to be cosine of 5 pi over 6. On the unit circle, cosine of 5 pi over 6 is going to be negative square root of 3 over 2, and that's my answer.